Hello students, I'm Sonali Kelkar from City International School, and today we are going to continue the third chapter of chemistry, that is metals and non-metals. So in this chapter we are going to take properties of metals and non-metals, reactivity series and formation and properties of ionic compound. So let's start today's session. So what happens when metals react with acid? So general equation for metals react with acid is metal plus acids gives you salt and it liberates hydrogen. So the hydrogen gas is formed in this reaction, right? So let's start with metal. Let's take a metal that is magnesium Mg, right? Magnesium Mg plus acid. Now in this case of acid, I want to tell you that these acids should be dilute, and the acid that we are going to take will be dilute HCl and H2SO4. H2SO4. So these are the acids that we are going to take in this reactions, right? Salt and hydrogen gas will be liberated. Magnesium plus, let's take first reaction of magnesium with H2SO4. H2SO4. So what is going to form? MgSO4, MgSO4 plus hydrogen gas is evolved. You have to remember that every time we are going to use dilute acids, we can use dilute H2SO4, dilute HCl, dilute carbonic acid, dilute phosphoric acid. And the next is, let's take aluminium Al plus H2SO4. This will make Al 2SO4 whole 3 plus hydrogen gas is liberated. Now coming to the next one, let's take zinc. Zinc plus H2SO4 gives ZnSO4 plus hydrogen gas, H2 gas is liberated. Now let's take Fe ion. Fe plus H2SO4 gives FeSO4 and hydrogen gas is liberated or evolved, right? Now let's balance the equation. Let's balance the first equation, MgSO4 as Mg plus H2SO4, MgSO4 plus H2. I think here everything is balanced. Now coming to aluminium, Al H2SO4, Al2SO4, H2. So balance it. So I'll make it 2Al because here it is 2, right? And then 3 I have to put here. Sulfur is 3. Oxygen gets 12, hydrogen gets 6 over here, hydrogen is 2, sorry, so I'll put over there 3. Now hydrogen is also gets balance, right? And rest of the things are balanced. Now in this equation, in these reactions, right, we have taken dilute H2SO4. I haven't mentioned here, but every reaction we are going to take dilute HCl and dilute H2SO4. Now if you want to find out which reaction is faster, I'll just erase it and make it dilute. Which reaction is faster? How will you come to know which reaction is faster? So to come to know which reaction is faster, we should know the activity series. Now this is a reactivity series in which all the elements are arranged according to the decreasing order of reactivity. So here you can see the potassium is the most reactive element, whereas if you go down the reactivity series, gold, or you can write here Pt, that is platinum, that is the least reactive element. Okay, after gold write platinum also, that is the least reactive element. Now when we talk about this, in these four reactions, which one is most fast reaction, okay, which happens very fast, okay, in which hydrogen gas is liberated more. Okay, so you can see where is the magnesium, here is magnesium, then comes aluminium, okay, and then comes zinc, and then comes iron. So definitely aluminium is going to react very fast and hydrogen gas will be released in a form of a bubble, right? I have put a GIF in the next slide where you can see how magnesium reacts with H2SO4 and liberate hydrogen gas. So liberation of hydrogen gas will be fast, will be more in case of magnesium. Why? Because according to the reactivity series, magnesium is more reactive. It is more reactive than the any other element which are mentioned here, than the aluminium, zinc and iron, right children? And can I write all this reaction with dilute HCl? Let's write all these reaction with dilute HCl, that is Mg plus HCl. This is also dilute, children, we have to be very careful, these all are dilute, okay, dilute acids. Mg plus HCl gives MgCl2, Mg plus HCl gives MgCl2, is it right? Magnesium plus HCl, right. Plus hydrogen gas is evolved. Then comes aluminium, Al plus HCl. What will form? Al. Aluminium has 3 valency, so that valency 3 will go at Cl. Chloride has 1 valency, so I am going to write aluminium as it is. Then H2, hydrogen gas is evolved. We have to balance this equation. 2A, then comes 6 HCl, 2 aluminium, 6 HCl, 2 aluminium here, okay, and chlorine also gets 6. Hydrogen is 2 here, I have to make it 6, so I'm going to put 3 here. Got it? Then comes zinc plus HCl gives you zinc chloride, ZnCl2, because chlorine has 1 valency, so that valency will go to magnesium, and magnesium has 2 valency, that valency go to chlorine. Here also zinc has 2 valency, that will go to chlorine, and chloride has 1 valency, that will come to zinc. Okay, so again hydrogen gas is evolved, because in the general equation we have seen that salt is formed and hydrogen gas is evolved. So every time that is going to happen. So let's balance the equation. 2Zn plus 2HCl gives you ZnCl2. Children, this is 2. Okay. Now coming to iron. Now iron definitely react with HCl. Okay. And we are getting FeCl2. This is iron 2. That is why we are getting FeCl2. Plus hydrogen gas is evolved, right? So here also this magnesium will going to react very fast. So hydrogen bubbles, you can see the hydrogen bubbles coming out from magnesium metal when reacts with acid, right? That will be very fast. So you can see that magnesium is the most reactive element. Why? Because it is at the top of the reactivity series when we compare magnesium with aluminum, zinc and iron, right? When we compare only these four elements, definitely when magnesium is at the top, so definitely the magnesium is more reactive than the rest of the element, that is aluminum, zinc and iron, right? And what is the other method by which you can make out that magnesium is more reactive? Because magnesium this reaction will be most exothermic reaction. Now what do we mean by exothermic reaction? That means it is going to liberate more heat. Okay, liberation of heat, it gives out more heat, right, as compared to the rest of the reaction, reaction of acid with the metals, right, aluminum, zinc and iron. Okay, now coming to the metal under hydrogen, that is copper, mercury, silver, gold and platinum, these are not going to react, no reaction is going to take place, not going to react, okay, react with dilute acid, okay, acid, fine. Now what about the reaction of the metal with HNO3 with nitric acid? Why we haven't considered nitric acid? Dilute nitric acid with HNO3, okay, dilute nitric acid, these all metals are not going to react, no reaction with dilute nitric acid. That means there won't be any release of, there won't be never ever any release of hydrogen gas in case of dilute nitric acid. Is it possible? No, because there are two metals, that is manganese and magnesium. They are going to react with very dilute acid. Very is very important keywords, students. Very dilute nitric acid, that is HNO3, and it is going to liberate hydrogen gas. They are going to react, but the nitric acid should be very dilute. What do you mean by very dilute? That means 1% of acid, 1% of acid, and the rest of the 99% will be water, right? Now the thing is, why these metals do not react with HNO3? Because because nitric acid is a strong, it is a very strong oxidizing agent. Oxidizing agent means it is going to give out what? It is going to give out oxygen. Oxidizing agent means gives us oxygen. Now this oxygen which is given out will react with the hydrogen. This oxygen, okay, let me write it in a bracket. This oxygen will react with the hydrogen which is released during the reaction immediately, and it is going to form what? Water, right? So water will be formed. That is why dilute nitric acid, here dilute nitric acid, HNO3 dilute, okay, dilute nitric acid is not taken in this reaction. Why? Because it is a strong oxidizing agent. So as soon as you mix dilute nitric acid, suppose you are mixing dilute nitric acid with zinc, so immediately hydrogen will be formed. It is not going to release. Why it is not going to release? Because whatever hydrogen is formed, it is going to react with oxygen and gives water immediately. So dilute HNO3 acid is not taken. So let's see for here reaction with acid. I have given reaction with acid, and here is a picture where you can see the magnesium strip. It is put in a dilute acid. It can be dilute H2SO4, it can be dilute HCl, right? It has put into dilute HCl or H2SO4, right? And you can see hydrogen bubbles are coming on the surface. Now how can you check out whether this is a hydrogen bubble? You can take a burning splinter, you can bring a burning splinter very carefully. This is very explosive reaction, right? You can bring a burning splinter and pop-up sound will come, right? Pop sound will come. So definitely this shows that this gas is a hydrogen gas. Now what about the copper? Copper, okay, we have seen in the reactivity series that copper, mercury, silver, gold, and platinum, they are not going to react with dilute HCl or dilute H2SO4, right? Because the reaction will be like this: dilute, see, copper plus HNO3, nitric acids give you copper nitrate, water and nitrogen gas will be released. So in these cases what happened? In case of nitric acid, water will be formed, and the nitrogen will change into either, the nitrogen will reduce to either NO2, either NO2 or N2O or NO. Okay, so the nitrogen, okay, so we can see here that hydrogen will produce to water, hydrogen is going to produce water, and then what will happen? Nitric acid itself will get reduced to any of the nitrogen oxide. Okay, so that is why nitric acid, dilute nitric acid is not advisable. So it doesn't evolve hydrogen gas when react with metal. Clear, student? And if I tell you copper plus HCl, that is dilute, will this reaction going to take place? No, this reaction is not going to take place, because all the metals which are falling below the hydrogen are not going to react with any kind of acid, right? And what happened when I write sodium react with HCl, or let's take potassium react with HCl or H2SO4, definitely it can be any. Okay, so I'm writing here dilute. Well, this reaction is going to take place. This reaction will be definitely going to take place, but it is highly explosive reaction, highly explosive, and it is not advisable to use this reaction or to do this reaction in lab. So it is not to be done in lab. This reaction is highly explosive. We are not going to do this reaction at any cost in the lab, right, students? So let's take further aqua regia. Now what is aqua regia? As you can see, the aqua regia, Latin for royal water. And why do we call it royal water? Because it is it can able to dissolve platinum, silver and gold, right? So this aqua regia, it is made up of, it is a mixture of hydrochloric acid, okay, freshly prepared hydrochloric acid and nitric acid, which are in the ratio of 3:1. So hydrochloric acid 3 and nitric acid 1. So they are in the ratio of 3:1. So this is called aqua regia, that is royal water. As you can see here, it is reddish orange in color. Children, now let's see reaction of metal with metal salt solution. Okay, reaction of metal with metal salt solution, right? So before we read the statement, let's look at the picture here. Now what is the solution here? We can see the solution is a blue copper sulfate solution. This is a copper sulfate solution, CuSO4 solution, right? Copper sulfate solution. And what we have put? We have put magnesium powder, that we have put Mg magnesium powder in a copper sulfate solution, and you can see there is a change in this reaction. Now this has become a colorless magnesium sulfate solution. Now this has become MgSO4, right? Magnesium sulfate solution, fine, and you can see the copper pieces here at the down, right? Now let's see the second picture. Over here again there is a copper sulfate solution, that is CuSO4, and we have put a iron nail that is Fe, we have put in this test tube, and after 15-20 minutes what we can see is there is a change in the color of the solution. Now this solution is nothing but FeSO4, that is iron sulfate solution, right? And you can see there is a deposition of copper over here on the iron nail, right? Look at the third picture. In this picture is copper sulfate solution, again CuSO4, a copper sulfate solution, and what we have put, this is I think this is zinc. Okay, this is zinc metal. We have put zinc metal in a copper sulfate solution, and what you can see here, the solution is become colorless, right? And copper started depositing over here. These are the copper, small copper particles deposited on a zinc metal, right? Now the solution is no more a copper sulfate solution. Now it is a zinc sulfate solution, ZnSO4, right? Now after we observe these all pictures, what we can see that we can see there is a displacement of metal from its salt solution. The copper is displaced by magnesium from the copper sulfate solution. Here we can see again the copper is displaced by iron from the copper sulfate solution. Again the copper is displaced by zinc from copper sulfate solution. Now if we see the reactivity series here, we can see the copper is over here quite down in the reactivity series, so this is less reactive. Okay, this is less reactive. But what about the first magnesium? Let's take the first one, magnesium, quite reactive, right? It's reactive. It is reactive than copper, we can see, right? And iron is in the next place. Of course, again the iron is reactive than copper. And what about the zinc? Yes, even the zinc is reactive than copper. So what we have concluded in this experiment, we saw that the copper, which is a less reactive metal, is replaced by the more reactive metal from its salt solution. So this is what is a reaction of metal with metal salt solution. So in these reactions, definitely the more reactive element is going to replace the less reactive element, or we can say the more reactive metal is going to replace the less reactive metal from its salt solution. So you can see the equations here, Mg plus CuSO4, MgSO plus copper, then zinc plus CuSO4, zinc sulfate plus copper, iron plus FeSO4, iron sulfate plus copper. So all the reactive element, that is magnesium, zinc and iron, okay, they are reactive than copper, so they displaces copper from the copper sulfate solution, that is the salt of copper, right? So now here, can I ask you one question? Is it possible that you have to tell me which reaction is possible? Fe plus ZnSO4, okay, is this reaction possible? Or Zn plus FeSO4, which reaction is possible? Now let's see the reactivity series. Which metal is more reactive? Zinc. So zinc is more reactive, so zinc is going to displace iron from iron salt solution. So this reaction is possible where zinc is going to replace iron. So we are going to get ZnSO4 plus iron. Okay, whereas this reaction is not possible because iron is less reactive than zinc. So iron cannot displace zinc. Here also we can do a vice versa reaction. I can put a copper wire in a iron sulfate solution, and if I put a copper wire in iron sulfate solution, there won't be any change. Why? Because copper is less reactive than iron. Now let's see, children, how do metals and non-metals react. Okay, this A and D and non-metals reacts. We know that metals are electropositive. That means they lose ions. When metal become positive, when they lose ions, then only they get positive, right? So let's see a metal over here, that is sodium, right? Now if you see the sodium, atomic number of sodium is 11 and electronic configuration is 281. Now, in the outermost shell, sodium has one electron. If sodium loses this electron, then sodium will get a octet state. Octet state is a very stable state, okay? And every element or every metal always try to attain octet state, right? Even the non-metal, by gaining electron, they try to attain octet state. So every element always try to attain octet state whenever and howsoever it is possible. Okay, now let's see the case of magnesium. Magnesium atomic number is 12, electronic configuration is 2, 8 and 2. Now it has 2 electron in its outermost shell. Now what do we call outermost shell? We call it as valence shell. And the electron present in the outermost shell are called valence electron, right? So it is easier for these metals to lose electron because they are 1, 2 or maybe 3 in case of aluminum, right? So they can easily lose electron. So they loses electron to obtain octet state. Here we can see the magnesium has lost electron, 2 electrons, and it has obtained a octet state. Now coming to the non-metals. Non-metals, they gain electron and becomes negative ions. So they are called electronegative elements. Why they can't lose electron? Because let's see the configuration. Now let's take the element chlorine. Here atomic number is 17. Now electronic configuration is 287. 7 is quite a high number of electron. They cannot afford to lose 7 electron. Instead of that, they will always try to get or gain 1 electron. Okay, so when it gains 1 electron, it becomes negatively charged ions. What are negative charge ions? Anions. Now let's see the state 288. So they have attained a octet state by gaining 1 electron. Okay, now come to the oxygen. Coming to the oxygen, see the atomic number is 8 and electronic configuration is 2 and 6. Now again, 6 electron, it is quite a large number of electron. They cannot afford to lose electron. Instead of that, they will always try, oxygen will always try to gain 2 electrons. So by gaining 2 electron, oxygen is attaining a octet state, right? Now coming to the formation of sodium chloride molecules, now we have seen that metals are electropositive in nature and non-metals are electronegative in nature. So one wants to lose electron and other wants to gain electron. So this can be a very good barter system. One can lose, other can gain, so they can easily come together. And why they want to come together, why they can come together, because they are oppositely charged. Sodium by losing 1 electron becomes positively charged. Chlorine by gaining 1 electron because becomes negatively charged. They are oppositely charged. Now this oppositely charged can attract each other. Okay, they can attract each other and they can form a compound which is a ionic compound. Why we call it ionic compound? Because because of the transfer of ions, or because of the transfer of electron. Transfer of electron, because transfer of electron, we call that these compounds are ionic compound. There is one more name of this compound, that is electrovalent. Electrovalent compound. Okay, compound and the bond formed between them. What is the name of bond? Of course, this is ionic bond, right? And this is known as, the other name is electrovalent bond, right? So there are two names of the bond and two names for the compound. Ionic compound we also call electrovalent compound, and the bond form is ionic bond, which is very strong bond, and we can also say other word is electrovalent bond, right? So here we can see the compound form is sodium chloride. Okay, now the atomic number of sodium we know that is 11. So according to the configuration it is 281, right? And chlorine is 287 electronic configuration. So this electron will be given to chlorine. So sodium will lose one electron and it will give it to chlorine. So chlorine will become negatively charged and sodium will become positively charged ion, and because of the two opposite charge they will attract each other and a bond will form between them, that is known as ionic bond, and that is very strong bond. Okay, now let's see the formation of magnesium chloride molecule MgCl2, right? If you see here MgCl2, there are two atoms of chlorine, right? So if we see the magnesium, we know the atomic number of magnesium is 12. Now let's arrange in a for electronic configuration. Let's arrange this in the different shell, that is 2H2. So the last shell is having 2 electrons. Magnesium can afford to lose 2 electrons, right? So that it will attain the state octet, right? So chlorine, we know that chlorine, one atom of chlorine always in the requirement of 1 electron to become a octet, to attain a octet state, right? So magnesium, this 2 electron of magnesium, one will be given to the one atom of chlorine, the other will be given to the other atom of chlorine, right? Now these 3 atoms will form a very strong bond and it will form a compound MgCl2, because in this bond there is a transfer of electron, right? There is a transfer of electron, there is no sharing of electron, right? Sharing of electron takes place in covalent bond, and this bond is electrovalent bond or ionic bond, where the transfer of electron takes place. Okay, so now let's see the ionic compound, electrovalent compound. Ionic compound are compound formed by the transfer of electron from a metal to a non-metal. Very important. Now let's see the properties. Before we see the property, you should keep in your mind that this bond is very strong, right? Bond between the metal and non-metal is very strong. So definitely the properties will be according to that. So let's see the property. They are formed by the transfer of electron and are made up of ions. Yes, we know that they are crystalline solid. These solids, crystalline solid means they are very strong solids with very high melting and very high boiling point, and when you apply a little pressure it will break. So they are brittle in nature, though they are solid, but they are brittle in nature. Okay, so the physical nature is ionic compounds are solid and are somewhat hard because of the strong force of attraction between the positive and the negative ions. So these compounds are generally brittle and break into pieces when pressure is applied, right? They have high melting point and high boiling point because of the strong bond, and these strong bond require high amount of energy to break down, right? So that is why they have a melting point, high melting point and high boiling point. Now coming to they are soluble in water. Yes, solubility, they are soluble in water, but they are not soluble in organic solvent such as petrol and kerosene, right? Now coming to the conductivity of electricity, right? Now, the conduction of electricity through a solution involves the movement of charged particles, right? So when I mix sodium chloride here, then I will get charged particles, that is sodium Na plus and Cl negative, right? Definitely the Na plus, which is cation. Okay, it will move towards cathode, and an ion, that is chlorine, it will move towards anode, and there will be a complete circuit formed. So we can see the bulb is glowing here when I mix sodium chloride, which is ionic compound, in water. So you can see that they are good conductor of electricity when they are mixed in water, and even when they are in a molten state. But they are not, they will not conduct electricity when they are in a solid state. Children, now let's see the question answers quickly, and I want you to write all this question answer in your notebook. Now let's start with the first one. Okay, write one example of each. A metal which is soft that can be cut with knife, and a non-metal which is hardest substance. We know it that metal which can cut with knife, sodium, okay, and potassium, that also you can write sodium and potassium you can cut with knife. Non-metal which is the hardest, that is diamond. Okay, a metal and a non-metal which exist as liquid at room temperature. So mercury is a metal, and the non-metal bromine is a non-metal. Now coming to the next question, mention the names of the metal for the following. Two metals which are alloyed with iron to make stainless steel. We know that it is it is nickel and chromium, right? Two metals which are used to make jewelry, gold, platinum, you can also write silver. Coming to this, write the following. A metal which is preserved in kerosene, sodium. Lustrous colored non-metal, iodine, right? And a metal which can melt while kept on a palm, gallium. And a metal which is poor conductor of heat, lead. Okay, now coming to the next question, state three reasons for the following fact. Sulfur is a non-metal, right? How sulfur is a non-matter? Yes, it is poor conductor of heat and electricity. Neither it is malleable nor it is ductile. Malleable, ductile, and sonorous. These are the three properties which can easily differentiate between metals and non-metals, right? Magnesium is a metal. Magnesium is good conductor of heat and electricity. It is malleable and ductile, right? And one of the reasons must be supported with a chemical reaction. Here you can see sulfur per oxygen give you sulfur dioxide. And we know that the oxides of non-metal are acidic in nature. How can we support? When you mix sulfur dioxide with water, you are getting sulfurous acid. This is nothing but a acidic rain. This is a reaction of acidic rain, right? Now, magnesium, we know that metal oxide are basic in nature. So magnesium plus hydrogen give you magnesium hydroxide, and magnesium hydroxide is basic in nature. We can test this with the help of a litmus paper, that is red litmus paper will turn into blue litmus paper. Okay, explain why calcium metal after reacting with water start floating on its surface. While the chemicals equation, okay, write the chemical equation for the reaction. Name one more metal that start floating after some time when immersed in water. Right, we know that calcium first initially gets settled down at the bottom, but as soon as when calcium react with water, what is formed? Hydrogen gas is formed. Now this hydrogen gas bubbles will take the calcium up in the up, that is on at the top of water. Then definitely we see that calcium is floating after some time. What is the other metal? That is magnesium. When react with hot water, we know that magnesium is the only metal reacting with hot water. Sodium, calcium, and potassium, sodium, calcium react with cold water. Magnesium react with hot water, and whereas zinc, iron reacts with steam. Okay, iron, zinc and aluminum reacts with steam. Okay, give the reason for the following. Aluminum oxide is considered as amphoteric oxide, and we have done that amphoteric oxides react, that is behaves they behave like acid as well as they behave like base. So when they react with acid, they form salt and water, as well as when they react with base, they form salt and water, right? Ionic compounds conduct electricity in molten state, we have seen, because when ionic compound, when you right when you apply a lot of heat, supply a lot of heat to ionic compound, it changes into molten state, and after that, ions, that bond is broken down. Then we can see there are free ions which can move and conduct electricity. Now coming to the electron dot structure for potassium and chlorine, you have to draw electron, that is dot structure, electron dot structure. Show the formation of calcium chloride by the transfer of electron. Name the ions present in the compound. Potassium and chlorine. We know the configuration of chlorine. Chlorine required 1 electron. We can see the configuration of potassium, right? Potassium, atomic number of potassium is 19, right? So 2, 8, 10 plus 8, 18 plus 1, 19. So potassium can easily afford to lose 1 electron. So this electron will be transferred to chlorine, right? So you can show the dot structure, electron dot structure, and reaction also you can write. Potassium loses 1 electron, you are getting potassium cation here. Chlorine gains 1 electron, you are getting anion, okay, or chloride ion, right? And you can show this type of reaction. You have to write everything step by step in your copy. State the electron dot structure of calcium and sulfur. So let's straight away go to the calcium. We know that atomic number of calcium is 20. So 2, 8, 10 plus 8, 18 plus 2, 20. Calcium is metal. Metals are electropositive. They lose electron. So here calcium has lost electron. Sulfur is 16. Atomic number is 16. So 2, 8, 6. 6 is 6 electrons are present in the outermost shell, cannot afford to lose 6 electrons. In fact, it can take 2 electrons to obtain a octet state, right? So sulfur is going to gain 2 electron, which is given by calcium, so it will become a sulfide here, right? And you can show this electron dot structure, right? And calcium ion, that is cation, and sulfur ion, that is anions, are present in CAS. CAS is what is a compound form. Now you have to show the electron dot diagram of chlorine. They have already given the atomic number and calcium 20. Show the formation of calcium chloride by transfer of electron. Calcium chloride. So calcium has 2 electron to give, and chlorine wants 1 electron. So calcium chloride, the formula is CaCl2. Okay, so 2 chlorine atom. Here you can see the 2 chlorine atom are getting 1 electron from calcium, right? So you can show the first electron dot diagram here. Then you can show the valence, the electronic configuration, and then you can show how the calcium ion is formed, chlorine ion is formed, and then you can show this, and the bond and the compound formed is calcium chloride. Okay, so identify the nature of the above compound. Definitely it is ionic compound, and we know the physical property of ionic compound. They are hard, they are solid, high melting point and high boiling point, and are soluble in water. They can conduct electricity when in a molten state as well as when they are in a water. So then next question, you are given sample of 3 metals, sodium, magnesium and copper. Suggest any 2 activities to arrange them in order of decreasing reactivity. We know sodium reacts, here you can give with acid also, and definitely with water also. Sodium reacts with cold water, magnesium reacts with hot water, and copper won't show any reaction with water. Coming to acid, definitely sodium react with acid, liberate hydrogen gas, though this reaction is not at all advisable to do it in a laboratory, okay, because this is highly explosive reaction. Then magnesium can reacts with HCl, it releases hydrogen gas, right? And copper won't react with dilute HCl or dilute H2SO4. So for that also reaction you can show and see the, you can write the order of reactivity, right? So this is a given with water and with acid. And explain the formation of ionic bond with calcium oxide with electron dot structure. Again, we have done so many questions with this these type of question we have done. So you can show them the calcium. We know that atomic number is 20, so arrange them, and calcium ion is formed, oxygen oxide is formed, how calcium and oxygen has you know transferred the 2 electron, calcium has transferred 2 electron to oxygen, and the bond is formed between them, okay, ionic bond. Then name the constituent metal of bronze. That bronze is made up of copper and tin. So this is all about today's session, children. Practice today's session, write all the question answer in your notebook, and thank